Hello, Baruch. Hello, Frank.
Hello.
So maybe we can add people some extra 3 minutes, then we can start.
Yeah, so I'm just sharing the link to the WhatsApp group. Yeah.
Frank, to mask. You're not protecting anything. I just started to highlight. Hello, Getnet. Hello, Gertrude.
I'm sorry, I don't identify that identity.
Tunatumia jina ID. Hope everyone can hear Kiswahili.
Yes, my name is Getty, not Gertrude.
Okay, Gertrude. Hello, Baruch. You had unmuted, yeah?
Hello.
Hello, how are you?
I'm well, thank you. How are you?
Hello, Esther. Hello, David. Kindly feel free to unmute and hello me back. Hello, Japheth.
Hello.
Okay, I guess our 3 minutes has elapsed. We can start. So I'll just give an overview on what we had done the previous Monday. So last Monday, we had started looking at ETS. And what we did so far was the introduction to ETS, how we can create an ETS table, insert a value into the ETS table, and how we can look at it. So we had some gambling on how different access types work. That was the protected type, the public, and the public. So we were trying it on IX, and we're trying it by creating different processes to see how that goes, and we didn't succeed. So maybe we can look at that as we proceed. Who can feel free to share their screen?
Hey, Teresi.
Yes.
Yeah, another thing that I
Are you
need
Gertrude?
to... Not Getty.
Oh yeah, okay, Gertrude, go ahead.
So the other thing that needs to be explained is why we're doing this approach of not preparing for the session So we learn as we go. The reason we decided on that approach, you might tell us if it's a good thing or not, is so that we learn the skill of looking up things that we don't understand, because we'll not be taught everything, but we might have an idea of how to do something. So it's there to teach us the skill of how can I look up something that I have an idea about, but I don't know how to use it. So it's more of developing that skill and again, learning about something new. So that's the reason we didn't have someone completely preparing for this and presenting something prepared. That's just a clarification I wanted to add.
Yeah. Thank you, Gertrude aka Sigu. Okay, so can we start now?
Yeah, we can start Elixir Conf Africa.
Okay, let me share my screen.
Tracy, you said that sharing your screen.
Yes, I'm sharing my screen.
Okay.
Just a minute. Can you all see my screen?
Yeah, we can.
So we had gone through the ETS as a cache. So here is where we left last time. So I will choose someone randomly so that he can start for us.
Okay, so last time what we did was how to create a new ETS table, how to insert a record, and how to get a record from it.
Yes.
Okay.
So Frank, you can start.
Yeah, I can. So where exactly am I starting from? At which point? Let's change.
Yes, there.
Okay. So let's change the key value registry to use ETS. Wait. Okay. First of all, I think I'm confused. This example that is up here, is it not a table, an ETS table?
At this point,
Yes.
it is an ETS table.
Okay. Then I think maybe we could go over. Okay, why don't we just do a quick overview of what we did last time so that we can get everyone on the same page. Because personally, I think maybe this example is related to, whatever I'm reading is related to this code example that it's up there.
Okay, so I will open my EX, then we can create the table, insert, and search for the value inserted, right?
Okay.
So, okay, so I'll start with the first one. So I'll just use their name. That is buckets registry. The option is the named table. So at that point, we have created a table called buckets registry.
Mhm.
Then we can insert a value in that
Okay.
table. We can insert something in that table.
So it's an empty table.
Yeah, for now it's an empty table.
Not like I'm seeing there's an option that you passed there.
Pardon?
There's that option that you passed when you're creating this new ETS.
Yeah, which is a named table.
Is there an unnamed table? Just thinking.
Wait, let's look at Elang docs.
Okay.
Yes, Elang. So here's the function new that we pass in the name of the table and the options. So we are given the kind of options that you can pass. Let me see.
Okay. So wait. Okay. So in the option, I can see there's type or access or named table. So these are all different options. So there's a type option. I wonder what that is. There's an access option. I also don't know what that is, but then I can see there's a named table option. So there's no opposite of named table. It's either named table or it is not a named table. But I don't know what is the difference.
Well, we can look at what named table does.
Okay.
Here, I found it. So we're told if this option is present, the table is registered under its name, which can then be used instead of the table identifier in subsequent operations.
Interesting. So that means that we don't even need that variable. If at all, we already know the name as to be, I don't know, what registry. So you cannot just use the atom, whatever that registry that we gave it to reference that ETS.
Okay. Pardon again. Pardon, please.
Okay. Will you just go back to the IEX session? Tracy, did you hear me? Okay, I think we've lost her.
Can you hear me?
Yes, now I can hear you. So we have created a new ETS table called buckets registry. Okay. So because this is a named table, we can always just use the name buckets registry and not the reference. So we always know that there's always just one table called buckets registry. That is if at all we pass the option named table.
Yes.
Hello.
Okay.
Hello.
Yeah, you dropped off.
Oh,
You
sorry.
are no longer sharing your screen.
Okay, can you see my screen now?
Yes.
Okay, you're saying something?
When I was just clarifying on the option named table and the reason why it's there. So when you pass that option, you always know like how you can always start a gen server and then you can always name it, right? You can give it some name. So instead of trying to access it using like the PID or the reference, you just use the name. So like in this case, we know that the name is buckets registry. So we don't need any reference. If at all we pass this name table, we can always just reference it using the name.
Yeah, that's what I've understood.
Okay. I think that clears up my confusion. Okay, you can proceed.
Okay, then we can insert a value into the buckets registry.
Mhm.
So the first argument will be the table name. I don't know if I pass it the table. And the value to be inserted. So the value to be
Since
inserted.
it's a named table, can we just use the name of the table?
Yeah, but let's try it if it will work.
Because it returns buckets registry. So I'm assuming this is what
Yeah.
the variable represent. So I'll give it a key of 4 and a value. I can give it anything as the value.
Mhm.
So we have something inserted in the table. Then after that, we can retrieve it, search it up.
You're supposed to use the table name.
Pardon?
We were experimenting with the table name.
Oh,
Instead of
I'm
the
supposed to use
reference.
the table name.
Instead of the reference.
Okay, so let me try it.
Just look up, but use the table name.
Bucket registry. So there it is.
Interesting. So if my assumption is correct, so we've inserted a record whose key is full and the value is, okay, I don't know what the value is. What is the value? Is the value both the key and the value?
The first, it's a tuple, right? The first meaning of the tuple, the first element is the key, and then the second element is the value, right?
Yeah, but whatever is being returned is the entire tuple.
The return value is the entire thing.
So can we say that this key is just an identifier of this entire record?
Exactly.
Okay. So there's not like a key value thing, but rather there's something identifying this record.
Yes. So
which is called a key.
yes. So you can always okay, because I believe keys are supposed to be unique, right? So in this aspect, okay, it's not literally be unique, but in your own context, right? It's supposed to be unique. So the moment you want to, because it also has an option of putting unique keys only, but you can also put keys which are not unique. So in this case, you want to access full, right? So since you know full, you can access the entire thing, right? You can access the value of full by just calling, by using the key full. So you get full and bar. And then so the return value will be both key and value. So the second element will always be the value of that thing.
So out of
I have a
curiosity,
suggestion.
Mhm.
Yeah, my suggestion is, I think, Frank, you might have missed the last meetup where we went into the detail on how almost all these work.
Yeah.
Yeah, we even tried this with the key being a list, and we looked at the value. So Tracy, you might be having access to the recording for last time, just so
Yeah,
that
I
we
do.
can make, so that we can make progress. We can continue from where we left after this recap, which I think we've recapped enough. Then if you missed last meetup, then you can watch that just to keep up. If you have any question, then you can ask it for the next meetup, during the next meetup. Yeah, because we went into the detail of all this.
Okay.
So to some of us, or most of us, it seems like a repetition of last meetup.
Okay. I can share the recordings on WhatsApp group that we are in Elixirkenya WhatsApp group, if it's okay.
All right, thank you.
Okay, we can proceed, Frank.
All right.
So yeah, Frank, are you in a position to continue with something you don't understand?
Okay. I'll be having questions along the way. Actually, my first question was going to be, what is this key value registry?
Okay.
So maybe I think maybe you could pick somebody who was there last time. Okopa, you there? Yeah, okay, then I think Okopa can proceed.
So I think I think we're supposed to create this key value is a module, right? So this module is supposed to change it to use ETS. Have we passed through the module?
No. So actually, we are at this step. Let's change.
Because it is
So
talking as if
a quick one. If you remember, we skipped the first part because for us to go through this ETS, we should have gone through some other things prior. So if we went through some other things, we'll be having kv.registry. So since we skipped that, we'll assume that we had it had some cache in it. So we're just trying to make it work with ETS.
Okay. Okay, thanks. Frank, can you continue to go on? Okay. So let us change that module, the kv.registry, to use ETS table. So the first change is to modify our registry to require a name argument. Thank you, Frank. So a name argument, we will use it to name ETS table and registry process itself. ETS names and process. Okay, ETS names and process names are stored in different locations, so there's no chance of conflict. So we will open up the file, that's the registry.ex file, and let's change the implementation. We've added comments to the source code to highlight the changes we've made. So yeah. So using Gen server here, right? So
okay. So the initial implementation for the registry was a Gen server,
yeah.
but you are now changing the storage to ETS. Okay.
So the first thing is the normal way of starting the Gen server, right? So the function is okay. First of all, you need to note the usage of the use Gen server. So we bring the behaviors Gen server here. So the start link. So pass the name to Gen servers in it. So in this case, we have.
Okay. Just my speculations. So whenever you're starting a Gen server, you give it options, right?
Mm-hmm.
So in this case, in the options that we are giving this Gen server, whenever it's starting, is the name of our ETS table.
Keyword, right? And something, it has a key call name, right?
What was a key call name? Or the options? Yes, but it's the name to
This ETS.
yes. So you're passing the name of the ETS to our Gen server.
Which will be the name of the registered process.
Sorry?
So at this point, we are passing, in our start link, we are passing the options, which is the name. Right?
Okay, we are passing options, and within the options, we have a key call name.
Yeah, we have a key call name.
Yes.
Is this name the name of our server or what?
It will be the name of our ETS.
Plus the name of our server.
Okay.
Because here at start link, we are passing the options of that third argument, which represent the name of the Gen server.
Also, it's the name of the Gen server.
Yes.
No, not really, because the Gen servers.
Look at can you open the kernel, the docs of the Gen server?
Hey, so let's quickly have a look at these. So in our options, there are some other options. So one of them is name. You get it from the option. So you do keyword.fetch. There's an exclamation mark. So in case you don't pass it in, that fails. And that is what we call server. Then just Gen server.start link, we start a new Gen server with the next option being the server and any other set of options that was passed. Okay. So we're still wondering what this server is.
Yes.
All right. So while we're wondering on that, let's look at the second one, which is lookup. We'll answer that later on. So lookup takes in the server and the name. So there's a comment there. Lookup is now done directly on ETS without accessing the server. So what you do is you go to ets.lookup, give it the server and the name. So we can intuitively, can I say, infer that server is basically the name of the ETS table at this moment. Because we're doing ets.lookup server and name. So server is the name of the ETS table. That's an inference that we can make.
Yeah.
That's correct, Frank?
Yes, that is correct.
Yeah, so if it returns something, which is the name and the PID, then we do pattern matching against that particular name. Then we return OK PID, otherwise we return the error.
Oh, yeah.
Yeah, so we can infer from what we see. Yeah, so I don't think these other details are important to us as to how ETS works. And it doesn't enable us understand ETS. True.
Oh, yeah.
Yeah, so any other part of ETS that is not yet clear other than creating, accessing, and looking up? Scroll down. Let's just scroll down. Continue scrolling past the code.
At that point,
Yeah. So there was this protected, public, and which other type of table can we create?
Private.
Private. All right. So there's the comment on the second paragraph. In order for the cache mechanism to work, the created table needs to have the protected, which is actually the default. So all clients can read from it, while only that process can write to it. We also have set the read concurrency to true when starting the table, optimizing the table for common scenario of concurrent read operations. So a lot of stuff can read from it concurrently. Okay, let's continue down. Yeah, that's adjusting the tests, which we don't need. So yeah, I think we can comfortably conclude that we can spin up an ETS table, we can create things in it, and we can look those things up, just in case we need to.
Yeah.
Yes.
there's this other thing.
Yeah.
Now that we have looked at the access types, that's the private, public, and protected.
Mhm.
So last Monday we were trying it on IEX and how we can create different process and try to see how the access type work. But
Okay.
we were okay. Can we say we were stuck?
We didn't get, were we really stuck, or we didn't get enough time to do that?
At first we were stuck, plus there was not enough time to do that.
Okay, so let's go to the documentation for ETS. Let's look at different access levels.
Pardon?
Yeah, there's the private. It's actually right there. Tracy,
The right side.
stop scrolling. Just stop scrolling. Yeah, it's right there.
Yeah, there.
Yeah. Could you scroll up, please? Okay, so let's have a look at all the set of options that you can give. So the parameter options is a list of options. So you give it a list of options that specifies the table type. That's the type of table that you're creating, how to access it, the position of the key, and whether the table is named or not, what Frank was asking about. So default values are used for omitted options. This means that if you don't specify, it is the same as saying that the table is a set, protected, then key position is the first element in the tuple. Then the other option is the header is none, write concurrency is false, read concurrency is false, then decentralized counters is false. So we can go through all these options and see what does these options do. If you don't specify any option, then the default, which are listed right above there, take effect. So what does set mean? Interestingly about the ETS, the options that you give is actually just a list. You don't specify this true, this false, this true, this false. As long as you give that option, then it becomes true. All right, so let's look at set. Set means that the table is a set table, one key, one object. And there is no order amongst the objects. And this is the default. If the key is name Elixir, then you can't have another key with name as name. That's a set. An ordered set is a table, one key, one object, and it's ordered in the Erlang term order. If you have an idea what the Erlang term order is, you can sort things ascending or descending. whichever the data type it is. Okay. So it's the order implied by greater than or less than operations. Table of this type have somewhat different behavior in some situations than table of other types. Most notably, the ordered set regard keys as equal when they compare equal. Whoa, okay. Not
So
only when they match.
how does it know if a key is ordered in ascending or descending order? Because if I'm assuming my key is 4 and I have another key, maybe bar,
So
and I specify ordered set, how will it know how?
It uses the order, the Erlang term order. It checks, there's a comment from, I think.
Yeah, you could try firing up an IX and compare 1,
maybe
4, and 4, an atom. You'll find that there's some order.
Yeah, you can go to IEX. So let's discuss the Erlang term order. You can compare anything to anything. IEX, no, don't scroll, please. Just go to IEX. Yeah, compare anything to anything.
Anything to
4 greater than bar, 1 greater than 3, 1 greater than bar.
like that.
Yeah, it always has an answer for you. Do any random comparison.
Quick
Of
one,
anything
is
with anything.
foo
Yes,
greater
Moshe.
than bar? Is foo greater than bar because of the alphabet? Because in this situation, it's binary.
Most likely, yes.
Yeah. So if I remember correctly, the Erlang term order is basically all data types in Erlang can be, there's a set order in which, like, if you, I guess you can think of it as like an alphabet or like sort of an ascending or descending order. So all the way from binaries to tuples to
PIDs.
I guess in the case of Elixir maps, everything in Erlang is part of an order, and that's I guess that's what you call the Erlang term order. So depending on what's fast in that order, if you have like a key that has different kinds of data types, then it's going to order them according to the data type, and then I guess within the data type according to, say in this case, alphabet. So if you're comparing, say, an atom, and I think you can even compare foo and foo. Foo as I think the best example would be, go ahead, foo as a binary, see what you get. So basically, binaries come before atoms in the Erlang term order, and it's documented. So I don't remember the exact order, but it's something that you can look up. If you compare maybe, say 1 as a digit and 1 as an atom and 1 as a binary, you'll see a pattern.
Yeah, compare anything to anything. Just experiment things out.
Yeah, so in this case, atoms come before. Is it? Okay, I'm not even sure. I'm a bit confused. But you should see an order of sorts.
In most languages, I know integer is usually greater than the other guys. So really.
No, in most languages, you can't compare one data type with another data type. Which other language can you compare an integer to a PID or an integer to a string?
I can't think of anything.
Can you compare a list to an integer? Is it really possible? Check. Oh, and Tracy, it doesn't have to be greater than only. You can.
Okay, I'm just
equal, less than, equal to, less
basically
than. Just
all the
creative. Just be creative.
Okay, we have that. So
yeah, any other language that can do this? I'm not aware of any other. It's maybe because I don't use them.
JavaScript has some weird things. I'm sure you can comparing a string to an integer.
Yeah, that's due to coercion. in JavaScript, coercion actually forces one data type to be another data type. So if you compare one with a string one, then it forces the one integer to be a string before it compares.
Okay.
It doesn't force the string to be an integer. It forces the integer to be a string, then compares the two.
Compares with. Okay.
Yeah, that's data
I
type coercion.
wanted
This
to bet on
doesn't.
Ruby. I don't know whether Tracy has IRB on his own. Oh, no.
Pardon, you wanted to?
I wanted to bet on Ruby.
I don't
know
have.
whether- Okay.
Oh, there's a comment on the chat. You can use info if you want details of what is comparing. How can we do that? Please give more context. Feel free to unmute and speak or just type it in. Do you have IRB, Tracy?
No, I don't have.
Oh, try. It's hard to miss Ruby in a Linux distro. Just open another tab
I
and
think I see
type
an example.
IRB.
So try, I guess, I and maybe a variable. So I guess info. Oh, you're checking out Ruby. Okay.
It's hard to miss Ruby. Yeah, it's hard to miss Ruby in a Linux distro. Oh, it's not there. Okay.
Yeah, and then I've sent an article by Dockyard that talks about the order of Alan types. And it's basically number is less than atom, is less than reference, is less than fun. It's a bit of a list of, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9 sort of data types. You can check the.
Yeah, Tracy can open up that
article. Yeah.
Just a minute.
So it's not just random. There's already a set pecking order in Alan. So it's not just random comparing maybe one as an atom and one as a binary. So I guess once you understand that order, you can have different kinds of keys as data types and use that ordered sets properly. Shuka kidogo. Drop kidogo. Yeah. I think this is it. Yeah. So that's the pecking order.
Oh, so can we say that if you're comparing two different data types, then it doesn't even check the content. It just checks which type is greater than the other.
I think it starts there.
Yeah.
And then once it gets to the actual data types, then it's probably going to do, so maybe
only if the data types are equal.
Yeah.
Mm-hmm.
Maybe, okay, if you're comparing a number and an atom, then the Alan term order kicks in. But if you're comparing a number and a number, then the ordering among numbers kicks in.
Oh, yeah.
Yeah, actually, this reminds me. I think I saw somewhere in the Elixir docs. They always tell you that actually when you check in the dates module, they'll tell you to always use the functions inside that module. So like if you want to compare dates, you should use dates.compare to compare those two instead of using the comparison signs.
Yeah, out of curiosity, more of an English thing, not Elixir. Why is it called a pecking order?
In a peck.
That's a good question. I think
Is it from the chicken hierarchy of things?
I bet it has something to do with birds.
Yeah, with birds and chicken.
Okay, maybe
it's
because
order, a hierarchy
sign,
of status.
That's
seen
that
among
bit of
members
a
of
sign and with the sign, the mouth of a
Can peck.
yes. You're pecking at, like the atom is pecking at number.
Wow.
Yeah, Mush was actually reading it out.
Okay, let me finish. A hierarchy of status seen among members of a group of people or animals, originally as observed among hens. Yeah, you're very right. It's hens. Yeah.
I can peck you, you can't peck me.
That's actually it. So I guess in like, what do you call a group of hens? In like a group of hens, inside whatever, the collective, noun is there. There's a hen that can't peck another one, but there's
Yeah, that's.
but
I wonder how that observation was made. You just sit it down and you're like, okay, that chicken can peck that other one. So after it's pecked, it goes and pecks the other one and the other one, and it doesn't go back up.
So we shall henceforth refer to Alan data types as chickens. And
any comparison is referred to as a chicken.
yes, and an atom can peck a number, and so on and so forth.
And
Let's
so on and
continue.
so forth,
We
yeah.
don't get technically derailed.
All right, so let's go back to the options. Now we know the pecking order. Oh, there was the suggestion of doing I and the variable to get more information about. Someone just stopped sharing the screen and we're using it. You get more information about that particular variable or whatever it is that you're using. So the next thing is, kindly reshare your screen. The second option was, so it was ordered set. It's ordered according to that pecking order, any of the keys. So the problem with that approach was, if you compare things that are considered as equals, then it thinks that the keys are equal. According to that statement, just go to that tab. So this means that to, most notably, the ordered, please stop moving your mouse, I'm getting confused. I think most notably, the ordered set tables regard keys as equal when they compare as equal. They don't have to be literally equal, but as long as the order compares them to be equal, then it thinks it's equal. So it doesn't have to be an exact match. So that means that in an ordered set table, integer 1 and a float 1 are regarded as equal.
Yeah, and
this also means that the key used to look up an element not necessarily matches the key of the returned elements. So if you mix up floats and integers, you might end up looking up the wrong values simply because the ordered set matched the wrong thing.
Because I was looking at it and my mind was like, you're putting the ordered set in dilemma. Maybe you had to throw away someone, but if that is still there, so that was what I wanted to experiment, but they've explained it there.
Mm-hmm.
Like if you put a float and an integer, and then I was wondering, since they say compare equal, what will happen in that case? What happens? Will somebody be thrown out?
Yeah, that is the ordering of whatever is there. Being thrown out or being retained does not depend on the order. That depends on, do you want unique values or you can accept duplicates? Okoth, can see you throwing your hands around. So my response to you is, what happens to the other equal does not depend on the fact that it's an ordered set or unordered. It's ordered set or not ordered. It depends on the fact that we can allow duplicates or we can't.
So this brings to my question now. Like, so since the comparison is being made in context of the term, right? And the terms which are considered equal, for instance, since integer and float are numbers, both of them are numbers and they have the same value, for example, 1 and 1.0. So they have the same value in the context of pecking order. What happens if you have not set the ordered set? You just let it be taking the option set. What happens? Since the keys are supposed to be unique, but here we have a case where
they are not supposed to be unique. There's nowhere where we've been told that the keys are supposed to be unique.
One key.
Oh, in the set. Yes, yeah. True.
So when you place,
one key, for example, one object, yes.
Yeah. So when I place a key of, or that does not bring uniqueness. So I put a key of 1. Oh, okay, I get it. I think I've just answered my question in my head, and I'll try answering it now, because I think the uniqueness is brought in context of, do they have exactly the same value? That's now the value is being brought in. But when you are ordering, the value does not matter. What matters is the pecking order of the terms.
Yeah.
What I mean by that is, when you place in certain, when the key is 1 and then we place another key of 1, then there will be a problem because they're the same value, 1 key, 1 value. So it means they're 1 key, 1 object. But in the second option, where I have that comparison will be in context of 1. In the first option, 1 and 1.0 are doing the same thing, right?
Okoth, can you experiment what you're talking about on IEX?
Okay.
Yeah, let's create a table and give it the values that you're talking about. Or we can use the
existing one.
Yeah, the existing table is a set. Or do we need an ordered set?
Yeah, we just need a set where I what I was saying is that in the first case, 1
So we
and
need
1.
a set.
Yeah, 1 and 1.0.
Okay, so we have a set. What's the name of the set? Registry lookup or something. What's the name of our table?
The variable table.
Yeah. No. Okay, we can use the variable
bucket
table.
registry. Yeah.
Oh, buckets registry, right. So let's insert another one for Okoth. What was the suggestion? Key and value?
I was suggesting the 2, so 1 and 1.0.
Which key? Okay.
Key 1.
So let's insert 1.
So a quick observation, the value of table is the atom.
Yes. It returns the name. If you say it's a named table, then actually the return value is the name of the table.
And if you if you don't use that, it's going to return a pip.
Yeah, a table ID, yes.
Okay.
The string 1.
I mean, the value can be anything.
The string 1, yeah, like that.
The key.
Okay, try and insert 1.0 and say the value should be float 1, maybe. Okay, so we can look up 1.
I want to see the error. Let's just try reinserting 1 again, but placing value to be 2. Just press the upper key.
I don't think there will be an error.
I also don't think there will be.
So it will be replaced, or what will happen?
No.
Since this is a set.
So query 1.0.
Yeah, just look up 1.0.
And then query 1. Interesting. Can you check everything? Can you like list everything that's the table? I don't know how to do that.
Yeah, so we can look that up.
Select
How do
all.
we select star? Select star from table. Tracy, how do you look up everything on the table? We can check on the docs. You're mixing a nice session.
Oh, I see an all function up there.
All, yeah, there's an all. But it takes 0 argument.
List.
A list of tables.
And that returns a list of tables.
That's not it.
Could you go and check how, I guess the other options for lookup? Maybe there's like, maybe you can put something empty and see what happens.
Okay, let's look up 2.
Yeah,
You're scrolling on the opposite direction.
Yeah, lookup. Well, that is the same lookup that we've been using.
Yeah,
Yes.
so I want to see if maybe there is the option to put a star, quote unquote.
How about lookup element? What does that do? Can we
Let's
look up-
disqualify this first. No, let's disqualify this that it can't work. Lookup.
Okay.
Let's confirm that lookup cannot do that. Then we can check on the next thing.
Okay.
Returns a list of all objects with the key in a table. So you must give it a key. So that can't do.
Yeah.
Look up all.
Look up element. There's no
Look up element. You must give it a key.
Yeah.
It can't be. And a position. So we can't use that.
So my wild guess is that the first one, it replaces the existing one, since it's supposed to be only one.
So it's
Okay.
a put, like I'm upload put.
Yes,
Yeah.
it replaces it.
So
What
we
does
just
table do? What does table do? The function table. Yeah, query list. Are we ready for such a thing? Query language. Okay, what does select do?
I'm going to take one again. Is that
Continuation. Continues the match started. No. Okay, let's cheat. Can we do table to list? Let's just cheat on that. The function table to list.
with the table to list?
Yeah. So it converts ETS. No. ETS. ETS dot table to list.
I
TAB
think you're right
tab.
about the tab to list thing.
Where's that table
Yes.
to list?
Tracy.
Okay.
Please,
Two.
after.
Just tab it
Tab
up.
and then the number.
No. Remove that. Patience. Remove
Tab
that
to
E. Remove E. Tab. No.
Yeah.
Remove 2. Yeah. So that's how it's supposed to be.
And then the name of the table.
Yeah, actually, Musha was saying let's cheat on this because I knew what you are looking for.
Yeah. So our stuff is there. Yeah, it's a replacement clearly.
Yeah, it does. So what if it was an ordered set? Our assumption is that if you look up 1.0, it might give you the first one.
And
Because
the
that
order,
will also match.
and I guess the order will be switching depending on the head of the brain of the ETS, whichever he decides to put first, because they're equal. He can decide to put 1.0 first, and then. So I think that can be also an issue there. Just a guess.
I agree with you. Okay.
Okay, so are we creating an ordered set?
Yeah, we're also out of time.
Yeah, we just ran out of time.
It was just warming up. Yeah, have a.
Did I just type in my IEX?
Yes, I wondered what that was about.
Okay, I was trying to type into the terminal, but it was not responding.
I don't know.
So
if
it
you are
was going
trying
into the chat.
to translate to Swahili.
Oh no, it's just forget about it. I was trying to type in the terminal, but
I'm
my
just
keyboard
clouding
focused
it.
on the wrong thing.
Number. What are we doing?
Creating an ordered table.
Okay.
Yeah, Tracy, I think, yeah. Then you can copy. What you're supposed to create a new table. You're not supposed to insert. Yeah, so you can copy the tuples that we have above. Foobar 1, 1, 1, 2.
IEX 14.
Yeah, 17. It's actually 17.
It has everything we want, right?
You can, yeah, IEX 17, not that one. I think you can insert it as a
We
list.
can insert all that stuff together. It
Let's
would
check
be
on
like-
insert.
Okay.
Check on the function insert.
Because I thought we were inserting one by one.
Insert all.
Oh, there's an insert all function. Yes.
So you can give it, the objects can be a tuple or a list of tuples. If you can see, yeah,
I see,
can you see that?
Yes.
Yeah.
I can't imagine the for loops you'd have to do.
Yeah. Line 17. Perfect.
Well, I think I've only used that B17 like feature in a tutorial. I am ashamed.
Wait.
That's interesting.
What is our integer?
1 was replaced.
Oh, because they're in the same order.
Wait, you guys,
Yes.
by the way, wasn't the name of table, wasn't the value of table changed?
Check line
Like
18.
when we created the ordered set table, we stopped referring to the old table.
Yeah, true. On line 18.
So what's up?
So now table refers to the new table, which is
So
ordered
if we want to
list
do our
set.
comparison, then we have to add those other items manually.
No, we've already added them.
Okay.
Okay, what's happening is we created a new ordered set table on line 18. Now our table is now our new ordered set table. Then secondly, we inserted foobar 1, 1 and 1, 2. But what happens in an ordered set is it checks if the key is the same, then it replaces the previous value. So it inserted foo and bar, it inserted 1 and 1. Then when it was going to insert 1.0 and 2, it got the value 1. So yes, so it has to replace it.
Interesting.
Line 20 is disproving my theory. And then I don't know whether there's a reasoning behind that. I don't know.
The Alan term order?
No, not Alan term order, but it has something. It has something to do with uniqueness. Because
so maybe according to this, 1.0 and 1 are the same thing. It's not thinking about integers or floats.
It's actually the same. Can you do 1 double equal 1.0 on IEX?
Are they using
Elixirkenya? Tracy at latitude is 6330. They're actually the same.
Yeah.
So the pecking order considers
this
to be the same. Yeah.
If I remember correctly, maybe I'm confusing with a different language, but if you put a triple equals exactly equal to, is that Alan, if I'm not wrong? Will it give us
JavaScript?
I think that's Elixir too. So there's a triple.
Yes.
I seem to remember something like that from Alan.
No. All
Yeah,
right,
so-
if you
so-
check on the pecking order,
Uh-huh.
check on the pecking order, both 1 and 1.0 are
At the
numbers.
same thing. Yeah.
They're
Exactly.
all numbers.
And no, look at the IEX. I mean, I
Yes.
get what you're saying. They are numbers, but if
Mhm.
you check exactly equal to or not exactly equal to, it's going to tell you that you need to differentiate them. But in
But I
terms of
think-
value, I think they're the same.
Yeah, in
like
terms of the pecking order, yeah.
Like 21 checks the, not pecking order, but checks the value of 1.0 and 1.
No, it starts by checking the pecking order. Then it
Okay,
realizes both are numbers.
And
Yeah,
then
Then
it
it
checks the
checks
number.
on their equality. Then it realizes they're actually equal. So if you want it to check on both equal in terms of value and data type, then you use the triple equal.
The second guy checks on the pecking order first, right? 22, I mean.
All of them. That's like the first check that is done.
I think 22 respects the pecking order first, right?
No.
So-
In the
okay.
pecking order, they are of the same hierarchy. On the pecking order, they are of the same hierarchy. They are all
So-
numbers,
The
both.
pecking order comes first. That is the first comparison.
It is the first comparison.
It's the first comparison, the pecking order.
Okay.
After that, that's when it falls back to the value.
Okay. So in this case,
If that was correct, then 22 would be
let's
true.
dissect this one according to your theory. So let's dissect it in that in context of pecking order, 1 and 1.0, they're the same, right?
Yes.
So what makes them then different related to that?
Okoth,
Because value, they're also the same.
Okoth.
value. Yeah.
Okoth, can I
Yeah.
guide your thinking?
Okay.
All right. So number one, let's agree on the pecking order. The pecking order says that if you are a number, then you're less than an atom.
Yeah.
Okay. So for any type of comparison you're supposed to do, we check, are you of a different pecking order? First thing. If you have the same if you have the same pecking order, now let's dive deeper into this. Do you agree up to that point?
Yeah.
All right, so let's do pecking order for 1 and 1.0. Are they of the same pecking order?
Yeah, they're the numbers, both of them.
They're both numbers. Perfect.
Yeah.
Second comparison is the value. Are they of the same value?
Yes.
No, they're not.
Yes, they are.
Both is-
So it returns true. Sawa. That is if you use double equal. If you use triple equal, it checks on the pecking order first because you can do, is it possible to do triple equal on 2 different data types? We can confirm that.
We can try.
If it's possible, then we check on the pecking order first before we check on the value. So triple equal must meet 2 conditions. They must have the same value and they must have the same data type.
Mm.
Yeah, we're waiting on the triple. Yeah, time is not on our side. Tracy, you can do 1 triple equal
Image and string.
a list. Let's just make it obvious, a list.
Mhm.
An empty list. Just so we don't start inferring. Yeah. Yeah, so the first thing that it does is it checks on the pecking order. Then it stops at the pecking order because that is what it uses to judge whether it's equal or not. Is that okay, Okoth?
Yeah.
Okay, what does it do next?
You check on the value.
If they were of the same pecking order, then it checks on the value and data type. Nisawa, is that
Mhm.
okay?
Mm.
Does that answer your question?
Yes, it does.
Okay, thank you.
Guys, as we finish, I have a request. If anyone finds like documentation for the Alan term order, because I'm trying to check and I can't find anything, please share. on Slack or on WhatsApp.
You mean some more detailed information about the order?
Yes, not a tutorial, but actual documentation.
There was a link there on the chat about the comparisons. I think we'll just check it out. I see it has everything. It has some documentation on the term order.
Awesome.
Yes. Yes, on the operators. Okay. So yes, can let's scroll down a bit. Yes, term ordering. There it is.
Great. I will read up on this for the next step. Thank you, Fons, for sharing.
Yes. So I think we could wrap this up.
Yeah,
For the
please.
session of an iPhone.
I enjoyed it, guys. Bye. I'm late.
Bye.
Right. Bye, everyone.
Bye.